Hello, everyone. Good afternoon. I've just enabled chat, so later on, if you have any questions, you can type it on here, or you can use the Q&A function in Zoom as well. So let me just check how many are in. I think we can start. Yeah, let me go ahead and start today's session. If you guys have any questions, just let me know. And this webinar would be recorded as well, so I'll be uploading it on EnGenius APAC afterwards, and then we'll also upload it on EnGenius Academy by end of the month. So today's session would be about a new series for EnGenius. So it's our new Broadband Outdoor Access Point series. So starting off with the EOC 655. So in the past, we have, I would say, many outdoor solutions, like, for example, the end stations, ENH, ENS models, which are used for point-to-point and point-to-multipoint. So some also use this for access point, so they connect client devices to it. So with the current solution that EOC brings right now, it's totally, I would say, elevated for EnGenius side. So it's not just your standard wireless bridges that you can buy off the shelf. So these are enterprise class bridges which can be used for wireless ISP functions, SCADA functions, and a lot more because of the capabilities. So I'll be discussing the introduction, and then I'll go over some other items pertaining to the EOC series. So any questions that you have, please let me know. So today I'll go over, like I said, the introduction. I'll have some overview, hardware specs for two models. So we'll be launching two models for the EOC 655 and 655C18. So I'll tell you more about the difference later on. And then we also have a set of software that you guys can use. So in the past, when we talk about point-to-point, I think we're lacking on the software side. If clients want to, let's say, manage point-to-point solution, you would have to go into individual interface, the web interface of each access point, base station, or CPE, to be able to configure it and link the connection. So with the EOC series, we're also launching a set of controller management solution, or NMS, to be able to manage outdoor broadband connections. So this have been requested a lot in the past. So yeah, we're excited to launch this as well. So EOC series for EnGenius. So like I mentioned, this is our fixed broadband access solution. So we use this for point-to-point, point-to-multipoint, for last mile, or your main bridge, your main backhaul for internet connection. So we're launching with two models, EOC 655 and C18. So 655 has dual radio. So all of our models are dual radio. Actually, three. I'll talk about the third radio later on. So it has two 5 gigahertz radios which act independently from each other. So that means radio 1, you can use this for your backhaul. Radio 2, maybe you can use this as your redundant link in case radio 1 fails. Or you can have them work separately. So maybe radio 1 faces the east side of your point-to-point connection, while radio 2, if you have an external antenna, faces the other direction if you want to do point-to-multipoint. So it's very flexible, this EOC series, and you can do a lot with it. So alongside the hardware, we're also launching, like I mentioned, a set of software tools that can help you. So one of those is SkyPoint. So SkyPoint will be our on-premise network monitoring system, or NMS, for all your backhaul system. So you can manage your base stations, you can manage your CPEs all together on the same platform. You'd be able to check the link quality, you'd be able to check the throughput if you want to do some speed test, throughput test, check your link quality, the jitter, and all that. You'd be able to do that through the software. So this is totally new for EnGenius side. So we also have a companion app which is called SkyConnect. So SkyConnect can be used to connect to the third radio of the EOC. So two 5 gigahertz radio and one 2.4 for management. So in case you want to manage the device directly from your phones, or let's say you don't have a laptop, you just want to manage the devices, you can straight away do it from here. So apart from that, we have high power for our outdoor models. It's all MU. It's all MU MIMO. It's all Wi-Fi 6 radios right now. And then we have a maximum data capacity of 2 gigabytes per second for the throughput. We also have features such as enhanced security. We have dying gasp, and then we have a built-in GPS as well as an antenna too for other models. So what does our EOC series bring? So I mentioned it's an elevated version of our existing bridges. So it's very high performance. It's highly capable. We have partners already in the US who are using this for wireless ISP deployment. Some telcos are using it there for broadband for bridging, for backhaul. It's rugged in design, IP67, so it's ensured that it's protected, just like the rest of our outdoor models that are IP based as well, IP67 based. It has dying gasp function, dying gasp. That means that, for example, the access point dies, maybe due to lack of power. So it's gonna send a last ping to the base station to inform you what went wrong. So maybe, for example, somebody powered off the access point, or there's something lacking, or there was an error that was experienced by your CPE. So it's gonna send that last ping, that last packet to your base station, so that you would have logs on your NMS to tell you that, hey, this went offline due to lack of power or something. So it's pretty intelligent in that matter. Configuration, the things that I'm talking about may sound complex, but simplified. The configuration is still very simplified. We have intelligent performance management, which means if you want to let the system work it out for you, let's say the interference, the channel width, etc., that can be automatically configured by our system. And then it also has built-in GPS, so that you would know where the access points are. It has a compass, it has a GPS, so that this can help you in terms of alignment, as well as tracking the unit. Maybe if somebody moves the unit to another location, you can easily pinpoint that from the map as well. So apart from that, in terms of the enterprise capacities, I would say we're on par with the enterprise point-to-point or bridging solution that are out there in the market. So we have automatic tuning of the radios. Since these are running Wi-Fi 6, I mentioned we have MU-MIMO. It has beamforming built-in, OFDMA, which allows us to have that huge capacity on the throughput. So we can offer 2 gigabytes link capacity on the Wi-Fi side. That means on the LAN port side, we also have multi-gig support. So on the hardware side, I'll talk about more later. So we have software features such as automatic RF corrections, outage response, which is for dying gasp. And then we have dynamic data rate. So that means on the fly, depending on your environment, your noise, interference, maybe your signal ratio as well, the data rates can automatically be adjusted to have the best throughput as much as possible. Of course, you would have options such as DCS, like what we have on the cloud. So dynamic channel selection, which would run through the system automatically. We have multi-tenancy on the central NMS as well. And it's auto-provisioning too. So for the sample applications on what the bridges can do, one of them, like what we have currently for our US market, is the wireless ISP sector. So they use this for their backhaul system as last mile, or the main backhaul for the wireless deployment. Let's say for hotspots, it would link to another radio to broadcast data, or maybe they want to link building to building communication, or they would use this for last mile connection to provide clients internet connectivity. So this can also be used for SCADA applications, video backhaul, especially if you want to, let's say, transmit your camera feed over wireless. This can also be used for mesh networks. It can be used for mining and other applications like that as well. By the way, when it comes to bridging, so like I mentioned, these are pure bridge products. They act for point-to-point and point-to-multipoint. That means subscriber clients, meaning mobile phones, laptops, they wouldn't be able to connect directly to these units, because these are pure bridge deployment. So the technology is a bit tweaked over OFDMA. It's kind of like how would I say, how EnGenius works, wherein you would have a radio to radio communication between the two hardware, but the communication is proprietary. So client devices won't be able to sync over wireless, because it's really dedicated for that backhaul, for that wireless point-to-point or point-to-multipoint connection. So we're launching with 2 products first. One is the EOC 655, which has 4 antenna connectors. So the EOC 655 is equipped with 4 external antenna connectors, which you can use with any type of antenna in the market. You can use a patch antenna, a dish antenna, or a sector antenna, depending on the requirement. And then we have the other model, EOC 655-C18, which comes with a built-in 8 dBi panel antenna. So straight away from the C18, you can have a bridge connection from this. So there are two 5 GHz radios. That means one radio would work with the internal C18 built-in panel antenna. If you want to add an external antenna that would run simultaneous with this built-in antenna, you can do so as well. So that would be running on radio 2. Now, with those running simultaneously, like I mentioned, they can be like facing backward each other, or you can have them work as a redundant link. Like radio 1 and radio 2 would have high availability or load balancing as well. So in terms of the hardware itself, it's IP67, so it's ruggedized. It's protected from water and dust. On the package, we have the included L bracket so that you'd be able to mount it easily and do quick adjustments. So all our units for the EOC series come with dual LAN ports. So 1 gig for the secondary LAN, and then 2.5G for your primary LAN. It can be powered up using standard PoE Plus PoE injector, which is also included on the box, or an external proprietary 48-volt injector as well. In terms of the antenna slots, they're all N-type, so they would work with any N-type antenna brand in the market as well. Grounding is also included on the box too. So the C18 version, which comes with an internal panel antenna, you would have two N-type connections for radio 2, and then you would have radio 1 dedicated for that 18 dBi panel antenna. So this is a good option for clients who just need a simple bridge without having to search for external antennas. Maybe they just need a simple point-to-point connection, or maybe point-to-multipoint connection as well, and they just want to make use of the device as is. So this would do like that. But of course, if you're going to use external antennas, you can enhance the range. You can have it deployed for miles and miles of connection. So one sample connection, if you're using, let's say, a dish antenna or a patch antenna with minimum beam width, maybe the antenna you have is 30 dBi, you can have about 20 miles of range. So that translates to roughly about 30 kilometers in terms of the distance. So from base station unit to subscribers unit or CPE. So point-to-point connection using like a dish antenna of about maybe 6 degrees, you can get roughly about 500 Mbps or 600 Mbps of data throughput. So with the EOC 655-C18, with its default 18 dBi antenna, you'd be able to get about over 1 gig of throughput over 3 miles. So roughly this is about 5 kilometers. Yeah, so this can also be used with point-to-point, like I mentioned. So you can mix and match the models. You can mix and match your design. So for instance, let's say here on this side, maybe you're using EOC 655, and then you have one antenna facing this direction. Maybe you have a 90-degree sector antenna or a 90-degree panel antenna. And then from the subscriber units, they would be bridged back to the unit. So if this is your topology, this is your setup, these can all be managed under the controller as well, which is a SkyPoint. So all the subscriber units links can be seen from there. If you want to do configuration on the remote site, you'd be able to do that as well on the system. And then if we're using the EOC 655-C18, so let's say on one side you have a point-to-point link using the internal antenna. And then if you use an external antenna on the other side, maybe to use it as a point-to-point bridge or point-to-multipoint link, you can do so as well. So it's very flexible. You can use it as a relay, a base station unit, or a subscriber unit as well. So having two independent radios from each other can give more flexibility for the installer. It wouldn't degrade the system. It wouldn't have any a downside if you activate both radios. So I would say it's a very versatile solution. So in the future, we'll be launching more models as well. So for the hardware specs, like I mentioned, it's all running Wi-Fi 6 for the current EOC 655 series. In the future, we plan to launch Wi-Fi 7 and Wi-Fi 6E as well. Maybe sometime next year or maybe end of the year. But now our focus is on the Wi-Fi 6 backhaul. It's triple radio, so you have your 2x2 5 GHz radio for radio 1. Radio 2 is 2x2 as well. 5 gigahertz, and then radio 3 would be for management. So it has a built-in 2.4 radio, which is used for management using the Sky Connect application. So security is there as well. It has built-in GPS so that you'll be able to track the unit. It's high power for the radios as well. And it comes with dual power options. So for redundancy as well as for additional power links. So maybe for LAN 1, you have your normal PoE connection. LAN 2, you have your proprietary or DC connection. So maybe you're using a solar connection for powering up the unit. So we give options for our clients. It has temperature and compass sensors built in as well. So this would help in terms of aligning the devices. Later on, I'll talk about the software, which would help you as well for alignment and for calculating your links. In terms of the software side, we also have dual image support for the firmware. So in case the first partition crashes, like with our switches, we have a backup partition that will automatically go up. 655 for the non-internal antenna unit, we have 4 N-type connectors, and then 2 N-type connectors for the one with the built-in antenna. So operating temperatures, I would say it's generous, negative 10 degrees up to positive 65 degrees Celsius for the operating temps. So I think for most of our regions in APAC, we should be able to cover the operating temps in the region. For the Ethernet ports, apart from the PoE functionality, LAN 1 can serve 1 gigabyte per second data, while LAN 2 serves multi-gig, so 2.5 gigabits per second. It also has a built-in 6 kV surge protection for electrostatic discharge. So all the radios come with dying gasp, so this is the last breath or the last ping that the AP will send to let you know what happened if it goes offline. So at least from the logs itself on the base station unit, you'd be able to see right away what's going on. Why did it go offline? Was it unplugged? Did it lack power? Was there channel change, etc.? So that would be, you'd be informed on the system. On the software side, so we're using proprietary radio communication for the access points to be able to have a good link. So less jitter, less latency, and maximum throughput depending on your current data rate. The support on the software side for the EOC is supported by both the mobile app and the Windows-based software, which is SkyPoint. And it's running on all, right now, 11AX technology or Wi-Fi 6. So per base station unit, either the C655 or the 655-C18, they can be changed into a base station or a subscriber unit or access point and CPE. So each base station radio can support 16 clients. If you want to have, let's say, multiple links or multiple relays, you can extend from there as well. We have dynamic bandwidth switching. So we support up to 160 megahertz channel bandwidth to give you that maximum throughput. But in case your radio detects, let's say, high noise in the area, you can set it to automatic or dynamic so that your bandwidth can drop to 80 megahertz or 40 megahertz depending on what you configure. So some unique features that we have is that we have an in-band spectrum analysis which you can run in the system. So without having to use external scanners, external hardware to scan the frequency in the area, you'd be able to run that straight away from the access point. So you can run this through our NMS, which we call SkyPoint, or in the future we'll also be updating the software of the access points so that you can see that directly from the unit. Let's say you're using it in standalone mode and you're not using the controller, you want to do spectrum analysis, you can do this straight away from the system as well. So we also have extended data storage so that you'd be able to upgrade for your point to multi-point link. So imagine if you have point to multi-point, maybe one base station talking to, let's say, 10 different subscriber units. You can load your firmware on the base station, and then from there, your subscriber units will get the firmware from your base station. So it's very flexible. So it can talk to each other, they can get the file from one another in terms of upgrading itself. So it'll be more efficient in your backhaul. We'll also be launching a light version of SkyPoint. So like I mentioned, right now, to be able to configure the system, we have the standalone setup, we have SkyPoint, which is the controller management, but we also be adding SkyPoint Lite in the future so that you'll be able to have more data straight away from your standalone mode, even without the access point. So we also have the compass built in, which would help you during alignment. So alignment usually is a tricky part, especially if you're deploying long ranges. Maybe once you hit like 1 kilometer, 2 kilometers, or 3, it'd be hard to like align your unit to point to the other end. So usually you would have to use external software just to have proper alignment. So since the unit has a built-in GPS and compass, you'll be able to really have a pinpoint alignment on where it is. You can key in your GPS coordinates from one end, so that the access point will tell you that, hey, you need to face me on this side to be able to align me to the pier. So the compass would help with that as well. So key features of the EOC series, again, it's the point-to-point and point-to-multipoint links, which are built in on the unit. So if in the past you need to have several radios to have, let's say, a relay or a backhaul, maybe you need to daisy chain multiple APs. With the current EOC series, you'd be able to use both radios to act or to serve both functions. So they can serve point-to-multipoint and point-to-point at the same time on the same access point. So dying gasp, like I mentioned, would help you a lot in determining what went wrong. If there's a problem on your unit, even if you have, let's say, multiple back-to-back radios, your last ping from that radio, when it goes offline, you would still be informed of what happened, because it will be passed over to the rest of the system. So to ease our clients in terms of deployment, we have the smartphone-based radio tuning, which is using Sky Connect. So you can link to the access point using the 2.4 gigahertz radio to manage the APs or to configure the APs. If you just want to get data, and let's say you don't have a laptop or a tablet on site to connect to the network physically, then you can use your mobile phone. So through the use of the GPS radio built in on the access point, you'd be able to do asset tracking. You'd be able to check if somebody tilted your radio, somebody moved your radio, or was there an accident which caused your radio to drop. So you'd be able to check that on the system as well. Now, like I mentioned, on the software side, we have a dual partition on the access point. So this is similar with our current lineup of switches. We have two partitions, so the active partition and the backup partition. So if ever something goes wrong, you would always have a backup for the access point. You can also make it so that you have two different configuration. Let's say on your active partition, you have this base config, and then let's say somebody configures the settings, and then you want to revert to that previous setting that you originally set. So you can do that as well on the system. You can set it up that way. So with a dual radio, you are able to have 2.5 gigabits per second maximum. So that means you can have a combined aggregated speed for both radios, or you can have it work in standby mode as a backup just in case. Now, to monitor and manage the system, first you have SkyPoint. So SkyPoint is your management software for the EOC series. So with SkyPoint, you have a comprehensive dashboard. This is on-prem, by the way. So you have a comprehensive dashboard. You can do auto discovery for your radios. So if they're on the network, or if you want to link them on wireless, you can easily link them using SkyPoint. You have your topology view, which is for your wireless access points. So because of the GPS unit built in on the radio, if let's say you plot the access point on your radio, it will be automatically plotted on the map. So instead of manually dragging them to have a rough position on where the AP is actually located, so it will automatically just sync itself on the map to tell you that, hey, I'm on this location, and then I'm paired to these radios. If I have mesh, it will tell me where the mesh link is. If I have multiple subscriber units connected to the base station, it will tell me as well. So you can get all that data on the software that you have. Of course, you can do configuration, you can generate reports as well, and you can get alarms based on what you configure on the system. So here's a sample on what it looks like. So depending on what you're viewing, you can see your triple radio deployment, you can see their throughput, their performance, you can see SNR. So there's actually a lot of data that you can get from here. So our R&D team have been working hard so that they can produce this information for everyone. You would see the hardware information, memory, throughput, temperature, how long has the AP been running. You can see the software version. You can see them on the map, which again is automatic because of GPS. You can see the jitter, latency, and so on. So there's really a lot of data that you can grab from this software. And it's not just doing it for a single radio, it's just doing it for all your deployments. If let's say you added multiple APs on the system and they're all linked together. So apart from that, you can also have your altitude information and your GPS coordinates too. And then we have Sky Connect. So Sky Connect is our iOS and Android tool, which can help you manage the radio. So you can use this to connect directly to the EOC. You can do auto discovery. You can configure. It can also help you in terms of the alignment. So it's going to give you information under the GPS. I believe this would also come with like a ping tool, like a how would I say, like an audible tool, which will tell you or which can aid you in informing you whether your alignment is correct. So as you move the access point to a certain direction or to a certain degree, it's going to beep to inform you that, hey, I'm getting close or I'm getting zoned in to that specific site. So in the past, a lot of clients have been requesting us for some alignment tool that can help us or that can help them in the point-to-point or point-to-multipoint deployment. So this would answer almost all of that requirement. So of course, this tool can also have you run tests like a speed test of your link, SNR tests, and other diagnostic tools that you want to run on the system. So here's a sample of the link test. So you'll be able to select 2 radios or multiple radios depending on which one you're connected to. And then you can also configure the direction. Is it uplink only or downlink only or both? And then you'd have information on your SNR, link quality, as well as your actual throughput. This is all running, by the way, all through the hardware. So all through the EOC. It wouldn't use any other external hardware to run these options. So other things that you can do from the system is you can back up your configuration. You can restore from there. You can upgrade a firmware. You can link this to another base station and so on. So there are a lot of things that you can do with Sky Connect. Now our third software, which we call Sky Link, it's more of a link calculator. So let's say you have 2 sites. You have the information in terms of the latitude, longitude, elevation, how far it is. Let's say for both sites, if you want to make a connection, and then maybe you're using an antenna, you state how much cable loss you have. So from there, you can get exactly how much data rate you would have on the system based on your configuration. So once you key in your credentials, once you key in the location information, it's going to give you the data rate. So let's say, for example, if you're using the maximum data rate, which is detected based on your configuration, then it's going to tell you the estimated throughput. So it's a very useful software so that you can know how much bandwidth you can expect on the system, whether you need to make adjustments on the power, adjustments on the antenna, or adjustments on the actual site to have a better link. So all the calculated information can be exported as well, so that you can easily present this to your clients. So this is what the generated report would look like. So it will tell you site 1 and site 2, how are they linked together, how far, what's the bandwidth, etc. So it's going to give you the estimated throughput as well. So this would be very, very useful. Again, this has been requested by a lot of our clients in the past. So yeah, apart from the alignment tool, so now we have the link calculator as well, so that you would know before the deployment what you would expect on the actual bandwidth that you would get, or the throughput that you would get, latency, and so on. So there's another tool that can help you as well in terms of finding your devices. So that's the Sky Locator. So for the EOC series, you'd be able to, let's say, scan the network. So once your PC is on the network connected to it, you'd be able to scan all EOCs that you're managing. So from there, you can back up the configuration. You can do factory reset. You can reboot the device and so on. So you can also pick up information right away from here. So all the 4 software. So Sky Point for managing, Sky Connect for managing using the app, your mobile phones, Sky Locator, and Sky Connect to check the link quality. And Sky Link. So all these 4 will launch all together when we release the EOC series as well. So I think we already have some information on the website about this software too. So let's say you don't want to use the software. Maybe you just have a couple of units that you want to link. Maybe you just want to configure it through the user interface. Of course, we have the standalone mode, in which you can also gather some data on the access point. You'd be able to like check your radio performance, your throughput. This is from the local UI. So you'd be able to see the uptime. You'd have information on your hardware as well. So IP address, location information, radio information, you can all configure it through the local user interface too. I don't have an actual unit with me yet, so I can't show you the UI. So hopefully this would do right now. But in the future, maybe we'll have another webinar for the actual demo, or linking the demo to hardware. So you have traffic shaping information, P2P information. So all this configurable settings over the radio can be done under standalone mode as well. So the spectrum analyzer that I was mentioning, so that can be run directly from the system as well. So here they're running the spectrum analysis on the 5 GHz radio. So radio 1 and then utilization on the bottom. So here you can see where the noise is, so that when you deploy, if you're going to use, let's say, manual channeling, you can set it based on here. So based from this channel, let's say channel 150 has the least noise. But of course, you can also do auto channel or dynamic channel selection and just leave the radios do the system configuration for you. So in the box, as usual, so everything that a installer would need would be directly in the box. You would have your access point unit. You would have the bracket that is required for pole or wall mounting. And then we would have Ethernet adapters with replaceable RJ45s just in case. And then of course we would have the PoE injector included out of the box as well as the grounding too. So for the installer, all he needs to do is to carry a box or two when deploying our EOC series, and basically everything that he needs would be there. So from there, the installer can just like use the Sky Connect tool from his application to link radios together, or if he wants to add it on an NMS, which is centrally located, maybe somebody's hosting it from a certain location, he can just straight away add it on the system as well. So the way that EOC connects, I just can show it right now, is, for example, you're going to connect a new EOC on the system. If you link it to, if you add it on your NMS, it will tell you that it's there, and then it's going to give you options on which bridge it's close to, where you can link it to. Do you want to establish the connection? So after you establish your credentials, the system will just connect it on your system, and you would see it right away instantaneously. So it's a very simple radio to configure, but of course it can be complex as well, depending on the type of settings that you want to customize. So we also leave it very customizable as well. So here's sample performance in terms of different data rates. So this was configured on the R&D center, and they have a couple of units set up using 2 different channel width. So this one right here is using 80 megahertz channel width. This one is using 160 megahertz channel width. So using 80 megahertz channel width at the maximum data rate, which is 1020 Mbps, actual throughput that they got using bidirection up and down is about 792 Mbps. At 160 megahertz, they got about 1549 Mbps. So that was simultaneously running on 2 different connections. So we have radio 1, which is setting up a point-to-point link, and then there's another independent point-to-point link under radio 2. So as you can see, you can have both data rates running simultaneously, both throughput, without having to affect each other. So radio 1 and radio 2, not much difference in terms of the throughput. So maximum data rate 1020 at 80 megahertz, they got about 800 Mbps on radio 2, and then data rate of 2040 Mbps under radio 2, 160 megahertz, they got about 1556 Mbps as the actual throughput. So this was run using the internal system NMS as well to get this data rates. Yeah, so I wish I could show you the interface, but I don't have the actual unit with me yet. Maybe in another webinar. But do you guys have any questions for now? Let me see chat and Q&A. Just a minute. Question here: what is the difference between speed test and throughput test? It's actually the same, just interchangeably used. So sometimes we call it throughput test, sometimes we call it speed test, but it's roughly the same. What do you mean external 5G antenna? Do you mean the unit comes with a SIM slot? By external 5G antenna, I think that was some part of the beginning of my slide. Let me just find it. This one. This means external 5G antenna. The 5 gigahertz antenna for EOC 655 is not included. Sorry, it doesn't have any internal antenna. So it uses an external 5G antenna for the EOC 655 model. For the EOC 655-C118 C18 model, it comes with an internal 18 dBi 5 gigahertz panel antenna. So sorry for the confusion. It's not a 5G cellular connection. It's actually 5 gigahertz radio. Any signal performance downside of EOC 655-C18 setup behind glass windows between two towers? So like our usual radio connection, because of physics, you may have refraction if there are glass windows between your deployment. As much as possible, if you're going to set up point-to-point links, we want the radio to have line of sight and no obstructions. If there is like glass windows between your two point-to-point links, maybe you would have refraction. Depending on the thickness, maybe you can get 18% refraction or 30% refraction. So that would affect your signal quality. But you would be able to test that in actual once you have it. But yeah, as much as possible, we would want to have like a clear environment without any obstructions in between. Is there auto channel and auto power and auto channel width? So yeah, we do have that on the system. So you can set auto channel, you can set DFS, you can set auto transmit power as well as dynamic bandwidth. So the system would automatically adjust your channel or power depending on the amount of noise and interference in the environment. So you can either do that manually or you can have the system set it up for you. So of course, if you have, let's say, 2 links and then you set it to auto channel, the system is intelligent enough to know that, hey, my pair changed to a different channel. So let me change to that new channel that it's on so that the link would be there as well. What is the distance between the P2P links? For the EOC 655-C18, if you're going to use the internal included antenna, roughly maybe about 10 kilometers tops, I would say. But again, that depends on the noise and interference level in the area. So since this EOC 655-C18 still comes with a second radio, which you can include another antenna, maybe a dish type antenna or a like a panel type antenna with a small beam width, and you can use any high gain antenna that you need. So you can have that distance extend even further as well. Okay, what is the maximum distance? Yeah, if you're gonna the maximum distance would really depend on the antenna that you use. If you're gonna use a, let's say, dish antenna with a very small beam width, like 6 degrees, 3 degrees, and say 30 dBi antenna, at the maximum transmit power of the EOC models, you can get about 20 miles. So this have been tested. So that's about 30 kilometers point to point. So another question here. Hi Milo, basically with point to point doesn't mean that we don't have to use fiber for uplink anymore. For the EOC series, it actually uses copper for the uplink. So your standard RJ45 connections, we have 1 gig and 2.5G for the LAN side. So one port is running 1G, the other port is running multi-gig. So 2.5G, I think that's more than enough to handle the throughput of our access point. You can also use this as a redundant link for your wired connection as well. So some of our clients do that. Hi Milo, can we know the distance range for the signal for the EOC 655-C18? So yeah, like I mentioned, maximum distance if you're going to use the internal antenna is roughly about maybe 10 kilometers for the C18. So depending on the noise, the environment, interference, But if you want to extend it further, the same model C18 can also be equipped with an external antenna, and it would depend then on the distance on how far it can go further. But for both models, 655 and 655-C18, both radios can be used independently. Okay, well, one question here is SkyPoint software deployment, is this on-prem or cloud? So SkyPoint is used for on-prem. If you want to load the software and centrally manage different sites, you can do that as well, so long as you have communication back to the SkyPoint software. But yeah, SkyPoint software is on-prem, so you can use this on your private network. Virtual appliance, is it available for on-prem deployment? Right now, I believe the system only supports Windows, if I'm not mistaken. But we'll let you know if we support VA in the future. But yeah, if you're asking about the controller itself and you don't want to use the SkyPoint software, you can also set up the access points by themselves or on their own. So you can set up a base station unit and then from there configuring it from the local user interface, meaning from its IP address. So once you access the IP address of the unit, you'd be able to configure the system as well. If you have multiple links or multiple points, so you will see that on the system. So for the installation, do we connect it to the nearest switch? So yes. So usually EOCs, this would act as your backhaul, your links. So going to, let's say, linking multiple sites or multiple branches back to your network. So that means from the EOC, you would have a LAN cable going down to your network. Maybe it's directly on your router, directly on a switch, or directly on a host or software. So it depends on your deployment. You can plug it on a switch, you can plug it on your host directly, let's say a PC or a server, or through your switches. Maximum distance with line of sight, yeah. So for the EOC series, we still recommend line of sight deployment, but the range is a lot farther than what we had in the past because of the technology that we use. So we're still using Wi-Fi frequency, but we're using a proprietary communication protocol to enhance the connection in terms of throughput, less jitter, and less latency. This is also the reason why client devices won't be able to connect to the radio, and the radio communication would be mainly EOC to EOC or multiple EOCs. Okay, so another question here, EOC 655-C18/20/C23. Oh, I think you saw on one of my slides, like there's another model. That model is still in planning. Basically, it's a model with a more higher gain antenna. So we have the C18, which means 18 dBi, and then C23, which is 23 dBi, which is a device can serve a farther distance. But this one is still in planning. The confirmed launch right now for EOC are these two. So EOC 655. The ones with external antennas, and then EOC 655-C18, the one with built-in panel antenna plus external antenna. Yes, so the C there corresponds to the antenna gain or antenna dBi. So 18 dBi, 23 dBi. Does the link calculation app include the height of the devices on each point? So yeah, the Skylink software, the calculator, can be used to calculate the links. It can help you as well determine the I think the elevation is what you're asking, the elevation of the devices. So this can be also used in our NMS, so or on the local UI. So as you configure the devices point to point, if one of your devices is elevated a bit higher because of the GPS, it can detect that. So you'd be able to identify where you should point the unit, at which angle, at which degree. So the system can help you determine your where you should point your device. The compass would help in conjunction with that as well. What about external antennas? Will EnGenius provide solutions for point-to-point or point-to-point? Do stay tuned for that. But for now, the ones that we have is the internal antenna. For external antennas, this one is still in planning. But what's nice is that since we have N-type connectors for the EOC series, you can use any antenna so long as it's 5 gigahertz and supports MIMO. So long as it's a 2x2 MIMO with a current lineup, 2x2 MIMO of a 5 GHz antenna, you should be able to work with our model, regardless of the brand. Okay, another question: between the units which acts as a bridge, do they establish their own IP or they require the same IP as their internal network? So the nice thing about the EOC series is that it's very customizable. You can have a DHCP server enabled on the EOC series, or you can have it run in bridge mode, which means that it will run off your existing router or DHCP server. You can also make it so that they're running on a totally separate IP. So maybe you have your wired network in a certain IP range, and then your bridge network on a different IP range. So you can work it out that way, depending on your setup. Okay, another question here: for the firmware upgrade in point-to-multipoint deployment, will it auto upgrade from the sub point-to-point unit and to the main unit accordingly? So yeah, you can do it on schedule. From what I saw in the software, so you can schedule the firmware upgrade. You can set it on the base unit. So for example, you loaded the firmware on the base station, one of the units, and then you set a schedule. So your subscriber units or CPEs would get the firmware from your base station instead of from an external server. So directly from your base station, the units can get the firmware as well. Or you can load it all on the units and then from there wait for the schedule for it to trigger the upgrade. So I would say firmware upgrades for these devices would be more flexible. Okay, so another question. For the EOC 655, you can connect one external antenna to the bottom and another one on top RF connections in order to have two different 5 GHz channels. That is correct. So since our EOC 655 and 655C18 has two independent radios, so you can have one connection on, you can have a 2x2 connection on radio 1, another 2x2 connection on radio 2, independently working differently. So maybe one is facing the east, another is facing the west side, and you're doing separate bridging. One side is doing point to point, the other one's doing point to multi-point. So the system can do that as well. So even with the one with the built-in antenna. So let's say you have the C18 doing a point-to-point bridge with the internal antenna, and then you have another external antenna, maybe sector or something else. So you have a sector antenna plugged in to the C18. You can have this do a point to multi-point work as well at the same time. So they run independently, so their channel can operate differently as well. So if one side is doing channel 36, the other one's doing channel 153 to have no interference, so they can do that as well. And all of those details can be reviewed or monitored under the NMS. So the NMS would give you a clear picture of what's going on, how are the links connecting to each other, what channel, what's the link quality, what's the jitter. I wish I could show you guys right now, but yeah, you would have the full image on the NMS software. Yeah, so the EOC may be new, maybe a new function or a new solution for EnGenius, but our team in the US have been using this for I think quite a while now. So they have several deployments with wireless ISPs and telcos in the US. Yeah, so again, for the EOC series, so these are enterprise class bridges for point-to-point and multi-point. So this wouldn't be your standard outdoor hotspot where clients would connect to it, because clients would not be able to associate to it on the SSID. So these are purely bridging devices. So we do have a broadcast on 2.4, which will be used by the installer as well for managing using SkyConnect. Okay, so if you guys missed the first part of this webinar, so again, this one is recorded. I'll be uploading it on YouTube. You can find it on our YouTube APAC page. And then by the end of the month, it will be uploaded on EnGenius Academy as well. If you need the slides, I can share it to our sales team. So after this webinar, maybe you can find our distributor or our regional salesperson to get the presentation slides as well. So any more questions, guys? Maybe I can take a couple more. Uh, 2.4 gigahertz, can we use this for serving clients for internet instead of just management only? So right now for the 2.4 gigahertz of the EOC series, this is really for management. I'm not sure if we can customize it to have internet access, but Since the antenna for 2.4 is built in, that means your range for 2.4 is very short. So you really wouldn't be able to have a hotspot solution because of the range of the 2.4. So it's really reserved for device configuration and management using SkyConnect. And for the slide, yes, I'll be sharing the slides to our sales team after this webinar. So you can just ask it from our distributor or our salesperson, regional salesperson. So yeah, if no more questions, I think that's it for today. So the next webinar would be, if I'm not mistaken, Nancy, is happening. Is that next week? Yeah, I think we have a webinar for next week for the PDUs, the cloud PDUs. Max station supported should be corrected from 16 to 32. Yeah, let me check on that. Last I checked was 16. If it was expanded to 32, let me check on that as well. Okay, guys, so see you on the next webinar, and thank you for attending today. You guys have a good day. Bye-bye.